Hello students, welcome to my YouTube channel Engineering Mathematics Made Easy for All. So in this we can see so many examples I have solved, and we have trained everyone very simple and very trick and very complicated examples I have solved in my YouTube channel. Today I am going to solve this example. Find the coordinate of center of curvature at any point of the parabola y square is equal to 4x. So before this I will just explain some definition, formula, and later I will come to this point how you are going to find the coordinate of the center of curvature. And you can see, yes friends, we are going to find its evolute. So we are going to find its evolute, students, very important. Today's topic we have evolute and involute. So just go to the brief idea about evolute and involute. Here we see in this differential calculus, students, curvature definition: the rate of bending of curve in any interval is called the curvature of curve in that interval. So just I have given definition. Curvature of a center we have already studied in my last video lecture. The curvature of a circle at any point on it equals the reciprocal of its radius. Very simple definitions we have. Radius of a curvature: the radius of curvature of a curve at any point on it is defined as reciprocal of the curvature. So all we have already discussed this. We just repeat it, and these are the very important formulas for examination point of view. Cartesian form of radius of curvature, this is the formula they have given. Parametric equation, please write down in your book, students. Radius of curvature when they have given parameters, and radius of curvature when we have the polar coordinates, and when radius of curvature when it is implicit form. So these are different forms we have. Then I have taken a simple chart that in when you take the curve, when we are going to take the what type of parameters we are going to form. Suppose if it is a parabola, we just take this parameters, and similarly on left hand side you can see if we take ellipse equation, the right hand side I have given the parametric form. Like left hand side I have given hyperbolic equation, what are the parameters I have given on the right hand side. So like this I have given few curves and their forms. Okay, here's the important part of today's lecture, that is evolute and involute. What is evolute? Yes students, what is evolute and involute? So already many other examples and videos are already shared. So today's topic will be very important: evolute and involute, how the examples are solved, and what is the meaning, definition, introduction, everything I'm going to discuss today. So please be there at the end of the video lecture. So just you can see, today we also study center of curvature. So please subscribe to my channel for more videos at to free, no any other cost. Internet definitely have to pay. Okay, so in this evolute and involute, the evolute of an involute of a curve is referred to that original curve. So in other words, simple, the locus of the center of curvature of curve is called evolute. So if you take any curve, you can just see in the diagram, students. Here I have already given. In this we can see this is locus of the center. Just take locus of the center of this curvature of a curve, and this we say this circle is going to become the evolute. From this evolute, the trace the curve, whatever the curve is going to trace, this curve is going to trace, then this trace of curve is nothing but evolute of the given evolute. So you just please remember, trace of the curve itself is involute. So involute and evolute is very simple. Then another example I have taken here. Suppose if you take, this is the same curve, similar curve I have taken, then with this lines, this is going to become our involute, and for this involute we trace the very simple curve, that is involute. So two diagrams are very important and very simple. They have explained about evolute and involute. Suppose the curves are very different from you, so that time in that cases we cannot go through or depend on what we say only sine, cos and different functions. Instead of that we are going to use this evolute and involute. With a large application we have, we just go through this runs one. So simple definition, we just go through a curve that is obtained by attaching a string which is imaginary and then winding and unwinding it totally on the curve given is called involute in differential geometry. Involute or evolute is the locus of the free end of this string. The evolute of an involute of a curve is referred to that original curve. In other words, the locus of the center of curvature of the curve is called evolute and the trace curve itself is called involute. This is part of special branch of geometry called differential geometry or curves. It talks about the smooth curve which lies in Euclidean space and the application of different methods of integral and differential calculus on them. The shapes related to some other curves are called involute. This was discovered by Christian Huygens in 1673. He was a Dutch mathematician and a physicist. Application, yes, very important application here we have. If you take a gear industries, there you can see to make the teeth for two revolving machines and gears we require this evolute. So this is very important. In different parts of the machines, especially for gears, we require exactly two evolute and its involute. So you can see two machines can be geared together so that it gives the correct grip. So what is this evolute and involute? Before this we see the envelope of this, the full envelope. The curve which touches each member of family of curve is called envelope of that family curve. The envelope of a family of curve, the locus of the ultimate points of intersection of consecutive members of a family of curves is called envelope of the family of curves. Very simple. Same evolute and evolute. If you take many families of curves, then it will become one envelope. That is the simple. We have properties of envelope and evolute. Property number one: the normal at any point of a curve is a tangent to its evolute touching at the corresponding center of curvature. So already I have discussed, if you take evolute, then there will be always many tangents touching to that curve. We have already seen in previous video lectures. The difference between the radii of curvature and 2 points of a curve is equal to the length of the curve of the evolute between the two corresponding points. Yes, length of the curve, I have derived this. We have derivation on this. We can just go through that playlist and you can find the derivation. There is one evolute but an infinite number of involute. Yes, friends, we can see if you take any one evolute or one curve, then there will be many traced curves or tangent to that curve. It will become an involute. So envelope of a family of curve touches at point of its touches at each of its point the corresponding members of that family. So this is the very simple way of properties. Now after understanding what is center of curvature and understanding evolute involute, I will just simplify the problem. Very simple. Yes, students, please solve. Okay, first you write down the formula of center of curvature. I think I have not given in this. Okay, let me give formula or center of curvature please take down the students. Yes, center of curvature formula is given as at a point. So center of curvature, that is the locus of that point. So I just say that this locus of point I'm going to take, let me select the pen. We'll take the point as x bar comma y bar. This is locus of the point where we are going to find the center of curvature. Then you can easily find what is center of curvature. Okay, so here we have x bar is equal to, please write down the formula friends. So this is x bar is equal to x minus y1 bracket 1 plus y1 square divided by y2 and y bar is equal to y plus 1 plus y1 square divided by y2. These are the two formulas you should remember here, students, to simplify center of curvature. After finding simplification, with this we will continue with the evolute. What is the evolute, students? Okay, so here we go. Same formula I can take here. So find the coordinate of a center of curvature at any point of the parabola they have given here, students. So we are going to find its very simple example. We'll quickly finish this. So write down the solution. So solution goes like this. If you take y square is equal to 4ax, just differentiate this ones with respect to x. So differentiation of y square to y1 is nothing but, if we take y1 is nothing but where y1 is nothing but dy by dx, and y2 we are going to take this as d square y upon dx square. So this is what we are going to consider y1 and y2. Okay, so therefore I'm going to take the y differentiation is 2y dash. Okay, immediately we'll simplify this ones quickly. Okay, this is equal to differentiation of 4ax. So 4a is constant, so I'll directly write this as 4a. Differentiation of x is 1. That implies y1 is equal to 2a divided by y. So this is our y1. Now again I will differentiate this with respect to x. This is also with respect to x. So this is going to become y2. Double differentiation. y2 is equal to, here I can just simplify, or I can say that y1 I can write this as 2a y raised to minus 1. Use the differentiation y raised to minus 1. So this will be 2a as it is, and differentiation of y raised to minus 1 will be minus y raised to minus 1. So this will be, simplification will be minus 2a divided by y square. So y square you know already, it is into, again in a differentiation, students, this will be y1. So if we simplify this, you will get this as y1. Is it clear, students? So you can just see what I have done here. Just taken the differentiation d by dx, y raised to minus 1. So minus y raised to minus 1 into differentiation of the inner product, that is dy by dx. So this is equal to minus 1 upon y square, dy upon dx I have taken y1. So therefore we can simplify y1 y1 value we know already here students, it is 2a divided by y. So minus 2a divided by y square into 2a divided by y. So that implies y2 is equal to, I will get this as y2 is equal to minus 4a divided by y cube. So this is how we find y1 and y2. Then we say that if suppose if I take x bar and y bar be the center of curvature, then we get the equation, that is the formula we are going to use from the above. Directly we are going to take x bar formula. I will take, please remember the formula students, x minus y1 1 plus y1 square divided by, just substitute the value students, x as it is, no change, minus y1 we have 2a divided by y, and 1 plus y1 square, it is 4a square divided by y square, we get the whole divided by y2 we have double differentiation of y, that is minus 4 a square, this is a square divided by y cube. Is it clear students? So like this we have to simplify and substitute. Yes students, easily we can simplify this. This is equal to x as it is, minus into minus, this minus and this minus will become plus. Here you have 2a divided by y, this 2a divided by y, we can easily see 1 y will get cancelled here, 1a will get cancelled, and 2 1s are 2 2s are you will get here, and then you can take LCM on numerator. So then you can get this y square plus 4a square divided by y square, the whole divided by, this will become 2, 1a is cancelled, so I will write here a divided by 1 y is cancelled, so I will write y square. So in this again you can see y square and y square will get cancelled, so therefore you will get x bar is equal to, this will become x plus y square plus 4a square divided by 2a. If you want you can simplify this one further, easily you can simplify. So this will be equal to, yes, 2a will take on this side, so this is going to become 2ax plus y square. Please remember what is y square, because y square is equal to 4ax we have taken already, so this is 4ax plus 4a square, the whole divided by 2. So further you can simplify this ones. So this is equal to, if you simplify, this is going to become, this is 6ax you will get, and this is going to become 4a square. So I will write like this, 2ax plus 4x, just for your simplification I will write this as 2ax divided by 2a plus this is 4a square divided by 2a. So a will get cancelled, 2 1s are 2s are, a will get cancelled, 2 1s are, this is 3. So you will get here 3x plus 2a. So this is our one locus of point, that is x bar. Similarly you can do it for y bar students. Please try for y bar. So y bar, please remember the formula, y bar is equal to y plus 1 plus y1 square divided by y2, which is equal to y plus 1 plus, we already seen y1, so I am going to take y1 square, so it will become 4a square divided by y square. The whole divided by y2. y2 is double differentiation of y. So this is minus 4a square divided by y square. So now again if you simplify this, friends, simplification is very easy. We'll keep y as it is plus we'll take LCM on this side in the numerator. So this will be y square plus 4a square divided by y square. Is it clear? The whole divided by minus 4a square divided by y square. Just have kept this as it is because y square will get cancelled. So therefore you must get this as y plus mm, y plus, you will get this as y square plus 4a square divided by minus 4a square. If you take this minus 4a square and this plus and minus will become minus, and if you take LCM this will be 4a square y minus y square minus 4a square the whole divided by 4a square, or you can simplify here only. Now you can simply substitute what is y square. Y square is nothing but 4a. So directly you can write it here also if you remember. So we can, instead of solving this, directly take here y minus 4ax plus 4a square divided by 4a square. So 4 will get cancelled. You can take common and simplify. 1a will get cancelled. So you may get like this, y minus y cube divided by 4a square. So therefore this will be equal to y, we already know what is the value of y. So I will take this as minus 2 x raised to 3 by 2 divided by root a. If you just simplify, you will get this value. Okay, then simplify this, friends. Substitute in x and y. So then we say to find the evolute, please remember this, friends, to find the evolute we have to eliminate x from x bar and y bar. So what we do, just I will simplify 1 and 2. You may get like this, y bar the whole square is equal to 4x cube divided by a, which is equal to 4 divided by a, x bar minus 2a cube divided by 3. If you simplify this, friends, simplification is easy. Take the cube and this will become 27a. I will take 27a on this side. So this will be 27a y bar square is equal to 4 x bar minus 2a cube. So when you take the locus of point, if you take the locus as x bar y bar, if you convert this to evolute, taking x comma y, the same equation can be taken as 27a y square is equal to 4x minus 2a cube. So this is very simple example we have done. Only thing you should know, the simplification, that is very important. Similarly, you can do the next example, students. Please try yourself. We'll give the next example. Example number 2. Show that the evolute of the cycloid x is equal to a theta minus sin theta, y is equal to a 1 minus cos theta is other equal cycloid. Same way you can simplify these ones. First to take y1 and then simplify x bar, then you can simplify y1 x1, substitute in the formula, you will get the answer. So here I will just give the hint. Please try yourself, friends. The hint is that here they have not given y value, so they have given two equations. So just remember, y1 I will take, that is dy by dx. So I will take here dy by d theta divided by dx by d theta. So this is nothing but differentiation of this y is equal to a into 1 minus cos theta. If you take, so a you will get differentiation of 1 is 0 minus cos theta, differentiation is minus into minus will become plus sin theta. So directly I will write a sin theta divided by dx by d theta. Differentiate this, x is equal to a theta minus sin theta. A is constant, so I will take a as it is. Differentiation of theta is 1 minus differentiation of sin theta is cos theta. So a will get cancelled, and then you can simplify this one. So this sin theta will become 2 sin theta by 2 into cos theta by 2. I have given the formula list, go through that and just see the formula. This is 2 sin square theta by 2. So 1 sin theta will get cancelled, 2 will get cancelled directly. y1 you will get this as cot theta by 2. This is how you have to simplify. Similarly, if you go for y2 is differentiation, just differentiate this cot theta by 2. So if you differentiate cot theta by 2, see that it is theta is a different variable, so you cannot differentiate directly. Therefore I will just take this as d upon dx y1, this is equal to d upon d theta. This is just simplification or arranging. So I will just take this as d upon d theta y1, okay, into d theta upon dx. So what I have done, I have divided and multiplied this d theta in the numerator and denominator. Okay, so now if you just simplify, you will get this in this form. So this is equal to cot theta by 2, that is y1. Differentiation with respect to theta will give you minus cosec square theta by 2 into 1 by 2. Chain rule, students, please remember this. Okay, and d theta by dx, we already seen it is a into 1 minus cos theta. So if you simplify, you will get this. Again, cos square theta by 2 is nothing but 1 upon cos square theta by 2, students, please remember, 1 upon sin square theta by 2, and 1 minus cos theta is nothing but again sin square theta by 2. So just in the simplification, what I say, this is minus 1 upon sin square theta by 2. This is as it is, 1 upon 2 as it is, into 1 divided by a into, yes, 1 minus cos theta is nothing but again sin square theta by 2. So sin square theta by 2 and sin square theta by 2 will be there. So here 1 sin square theta by 2 sin square theta by 2, I will take this as minus 1 upon 2 into 2 will give you, here we have 1 upon 2 and this is 2 sin square theta by 2. This will give you 4 a sin raised to 4 theta by 2. Okay, this is what we get y1 and y2. Then directly substitute in the x bar and y bar. Suppose if x bar y bar be the center of curvature, then x bar we will get here, students. Please remember x bar is equal to x formula. Then substitute what we have, x minus y1 plus y1 square divided by y2. What is x? They have already given this as a theta minus sin theta plus the next what they have given, minus, sorry, this is minus. Okay, minus y1. What is y1? Please remember, already we have simplified is cot theta by 2. Then next 1 plus, I am substituting the formula I have given in the previous slide, so just I have taken that same formula, 1 plus y1 square. So y1, please remember, students, I will take this as cot square theta by 2, the whole divided by y2 minus 1 divided by 4 a sin raised to 4 theta by 2. This is what we get the value, friends. Okay, just simplify this, friends. Cot theta by 2, I can write this as cos theta by 2 and sin theta by 2. 1 plus cot square theta by 2, we can take this as cosec square theta by 2. So just simplify here, last line. I think I am giving hint or I am solving full example, I don't know. I think I am solving it. Okay, a theta plus sin theta, and this is minus cot theta by 2, I will write this as cos theta by 2 divided by sin theta by 2. And the next 1 plus cot square theta by 2. 1 plus cot square theta by 2 is nothing but cosec square theta by 2. And if you see this minus 1 into minus will make this plus, and 4a sin raised to 4 theta by 2 I will take in this numerator, so it will become 4a sin raised to 4 theta by 2. This is what you will get the simplification. Further, if you see a into theta plus sin theta, and then here sin will get cancelled, here we have cosec will get cancelled. Then after simplification it will look like this, a theta plus sin theta, sorry, I think I have taken here plus, it is minus, then plus 4a sin theta by 2 into cos theta by 2. Remaining terms will get cancelled, friends. So further, what is this? You already seen 2 Sine theta by 2 into cos theta by 2 is nothing but sine theta. So if you simplify, it will become 2a sine theta. If you open this bracket and simplify directly, would write the answer, it is a theta plus sine theta. You must get. Yes, please try this once. Okay. Next, I will take this as next formula y bar. Please remember the formula, students. Y plus 1 plus y1 square divided by y2. So what is y? It is a 1 minus cos theta plus 1 plus y1 square. So 1 plus y1 is cot square theta by 2, and next you can see this is divided by y2. y2 we have minus 4a sine raised to 4 theta by 2. That I will take it here directly as I have done here. So same way I will take it. It is minus 4a sine raised to 4 theta by 2. Plus into minus will become minus, and 1 plus cot square theta by 2 will become cosec square theta, right? And that cosec square theta will cancel with sine square theta. 1 sine square theta will get cancelled, or we will just see a 1 minus cos theta plus this is cosec square theta by 2 minus 4a, this is in bracket, please remember that, sine square theta by 2 into sine square theta by 2. It is nothing but sine raised to 4 theta by 2. So 1 sine square theta by 2 will get cancelled. This will become a into, open the bracket front and simplify. You will get this as a into 1 minus cos theta minus 4a sine square theta by 2. Again you remember the formula, students. Sine square theta by 2 is nothing but 1 minus cos theta. So that will be a into 1 minus cos theta. Here it will be minus 2a 1 minus cos theta. So if you simplify this, you must get this answer as a into 1 minus cos theta, that is y bar. So that means that, students, what will be the, hence the locus of point, what will be the locus of point? Hence the locus of point, locus of x bar comma y bar, that is the evolute. Please remember, students, it is evolute, which is given by x is equal to a theta plus sine theta, y is equal to minus a 1 minus 1 minus cos theta, 1 minus cos theta. You can see a strong switch is another equal cycloid. So like this you have to simplify this ones. Thank you so much for watching the video. You can see many more videos such in future. Please subscribe to my channel, Engineering Mathematics Made Easy for All, and I have playlist. Please go through the playlist once again. Thank you so much, friends. We'll continue in the next class.